Welcome, dear friend, to a very special journey tonight. We invite you to step away from the familiar confines of your everyday world. Together, we will venture far beyond the stars into the silent, boundless expanse of the cosmos. This is not merely a trip of distance, but a voyage of discovery designed to touch the deepest parts of your being. Imagine yourself floating gently, leaving behind all earthly concerns, as we embark on an exploration of infinite beauty and profound mystery. Let the vastness of space cradle you, and allow its ancient wisdom to unfold before your mind's eye, preparing you for a truly peaceful experience. Our voyage this evening has a dual purpose, both equally important for your well-being. Firstly, it is a journey to enlighten your mind, to share with you the incredible stories and facts about our universe. We will touch upon the grandest scales of existence, from the birth of everything to the intricate dance of galaxies. But this enlightenment is not meant to be strenuous. It is gentle, like the soft glow of distant starlight. Secondly, and perhaps more importantly for this moment, our journey is designed to soothe your soul. We aim to create a space of profound calm, where worries dissipate like morning mist, and a deep sense of peace can settle over you, preparing you for restful sleep. As we begin, please allow yourself to settle into a state of complete comfort. Find a position that feels truly restful for your body, whether you are lying down or comfortably seated. Let your muscles soften, releasing any tension they might be holding. Take a slow, gentle breath in, and as you exhale, imagine all the cares and anxieties of the day drifting away from you. Feel the support beneath you, holding you securely, allowing you to let go even more. There is nothing you need to do, nowhere else you need to be. Imagine for a moment the sheer vastness of the space that surrounds our small world. It stretches out in all directions, seemingly without end, filled with wonders beyond our everyday comprehension. In this immense cosmic ocean, our Earth is but a tiny, precious island of life. Contemplating this immensity can sometimes make us feel small, yet it can also connect us to something far greater than ourselves. It reminds us that we are part of an enormous, interconnected system, a universe teeming with potential and silent, unfolding stories. Let this feeling of connection wash over you, a sense of belonging to the grand cosmic ballet. In this vast expanse, every single star you might see, and countless more beyond our vision, tells a story. Each point of light is a distant sun, much like our own, perhaps warming planets that orbit it. These stars have their own life cycles, their own histories, stretching back millions or even billions of years. Some are young and fiery, blazing with youthful energy, while others are ancient, nearing the end of their long existence. They whisper tales of creation, of fusion, of the elements they forge within their hearts. Tonight, we will listen to these stellar narratives, allowing their ancient light to illuminate our path to tranquility. Beyond the stars, every planet holds its own unique secrets, its own silent invitation to explore. From the scorching, barren landscapes of worlds close to their suns, to the icy, mysterious realms in the distant cold, each planet is a chapter in the story of celestial formation. They whisper of geological processes, of atmospheres thin or thick, of the possibility of hidden oceans or ancient dried-up riverbeds. These celestial bodies are not just inert balls of rock and gas. They are dynamic worlds, each with a past, a present, and a future. Their quiet presence in the darkness beckons us with a sense of profound wonder and gentle curiosity. And further still, entire galaxies, like colossal islands of stars, beckon with even greater wonder. To fully embrace this journey into the cosmos and allow it to guide you to rest, let us first ensure your body and mind are perfectly prepared. Find that position where you feel most at ease, where every muscle can release and soften. Perhaps you are nestled in your bed, cozy under a warm blanket, or resting in a comfortable chair. Allow your limbs to feel heavy and relaxed. Let your jaw unclench, your shoulders drop, and your brow smooth. Your only task now is to be comfortable, to create a sanctuary for yourself where peace can easily find you. This physical ease is the foundation for the mental calm we seek together tonight. Now let us turn our attention to your breath. Your breath is a natural anchor to the present moment, a gentle rhythm that can soothe your entire being. Begin to breathe slowly and deeply, but without any strain. Inhale gently through your nose, feeling the cool air enter and fill your lungs. Pause for a moment and then exhale slowly, perhaps through your mouth, letting the air carry away any lingering tension. Imagine with each inhalation, you are drawing in peace and calm. With each exhalation, you are releasing worries and distractions. Feel the gentle rise and fall of your chest or abdomen, a natural calming cadence guiding you deeper into relaxation. As you continue to breathe softly, be aware of the gentle sounds and visuals that accompany this narrative. Soft, ambient music may be playing, designed to complement the stillness of space and the quietude of your mind. The visuals, if you are watching, will be slow and flowing, depicting the serene beauty of the cosmos. Our journey tonight will be an odyssey, a grand exploration of the universe's most captivating wonders, all experienced from a place of deep comfort and peace. We will begin at the very dawn of time, witnessing the incredible moment of the Big Bang, the genesis of all space, time, and matter. From there, we will watch as the first stars ignite and galaxies begin to form their majestic spiral structures. We will then delve into the fascinating lives of stars, from their birth in vibrant nebulae to their often spectacular departures. This journey is designed to be both enlightening and profoundly soothing, a gentle unfolding of cosmic history. While this voyage is indeed educational, its primary purpose is to foster a sense of awe and tranquility. As you learn about the vastness of the universe and the intricate processes that govern it, allow this knowledge to deepen your appreciation for the cosmos rather than overwhelm you. There is a profound beauty in understanding, even in a small way, the grand mechanisms of existence. Let this understanding be a source of comfort, a reminder of the incredible order and creativity inherent in the universe. Knowledge, when received in a state of relaxation, can be a powerful tool for expanding your mind while simultaneously calming your spirit. This experience is also deeply meditative. By focusing your attention on the serene and majestic imagery of space, you naturally draw your mind away from the persistent thoughts and worries of daily life. The sheer scale of cosmic phenomena can help to put everyday concerns into a broader perspective, diminishing their power to disturb your peace. As we journey together, we are not just observing the universe, we are connecting with its timeless rhythms, its silent grandeur. This connection can foster a profound sense of inner calm, allowing your mind and body to synchronize in a state of harmonious relaxation. Ultimately, our shared odyssey through the stars is designed to lead you to a place of deep, restorative sleep. As we conclude our exploration, the final segment will be a gentle meditation, guiding you to let go completely. The wonders we have witnessed, the knowledge we have shared, and the peace we have cultivated will all serve as a soft cradle, rocking you into a serene slumber. Our cosmic story begins an unimaginable time ago, around 13.8 billion years in the past. Before this moment, the concepts of time and space as we understand them did not exist. Imagine, if you can, a point of infinite density, a state of boundless energy and temperature, all contained within an infinitesimally small singularity. This was the very seed of our universe, a beginning so profound it encompasses everything that is and everything that ever will be. Let your mind gently rest on this idea of an ultimate origin, a single silent point holding the potential for all creation, a quiet genesis before the grand cosmic dawn. From this indescribable state, the universe did not explode in a chaotic burst, as the name Big Bang might suggest. Instead, it began a process of immense and rapid expansion. Space itself started to unfurl, like a magnificent cosmic flower blooming in an unknown void. This expansion was not into a pre-existing emptiness, but rather the creation of space itself, carrying energy and nascent matter along with it. Feel the gentle sense of this unfolding, a smooth and continuous expansion that continues even to this day, a quiet, persistent movement shaping the fabric of reality. It was a birth, a gentle commencement of existence. In these very first moments, the universe was an incredibly hot, dense soup of fundamental particles and energy. It was a seething, vibrant environment, far too energetic for even the simplest atoms to hold together. Imagine a perfect, undifferentiated plasma, where everything was one, a homogeneous mixture of pure potential. As space expanded, this primordial soup began to cool, a crucial step in the journey towards complexity and structure. This cooling was like a slow, cosmic exhalation, allowing the universe to settle, to prepare for the next stage of its incredible evolution, a gradual calming after the initial burst of being. This primordial spark, this gentle unfolding, set the stage for everything that has followed. From this singular event, all the laws of physics emerged, all the matter and energy that would eventually form stars, planets, and even ourselves. As the young universe continued its serene expansion, it also continued to cool. This gradual decrease in temperature was an essential process, a gentle release of the intense initial energy. Think of it as a soothing balm spreading through the cosmos, calming the fiery conditions that prevailed at the very beginning. With each passing moment, the universe became a little less dense, a little less hot, creating the conditions necessary for the first structures to begin to form. This cooling was not a sudden chill, but a slow, steady transition, like the fading warmth of a fire as it settles into glowing embers, preparing the way for new possibilities. In this cooling environment, fundamental particles like quarks and gluons, which had roamed freely in the earliest inferno, began to combine. They formed the more familiar building blocks of matter, protons, and neutrons. These tiny particles emerged from the primordial energy, like the first distinct notes in a grand cosmic symphony. They were the seeds from which all future matter would grow. Imagine these fundamental components gently coalescing, drawn together by the emerging forces of nature, taking the first steps towards a more structured existence. The universe was slowly, patiently assembling itself piece by tiny piece, in the quiet vastness of expanding space. After several 100,000 years of further cooling, a truly momentous event occurred. The universe became cool enough for protons and neutrons to capture electrons, forming the very first atoms. These were primarily simple atoms of hydrogen and helium, the lightest and most abundant elements. With the formation of these neutral atoms, the universe, which had been an opaque fog of charged particles, suddenly became transparent. For the very first time, light could travel freely across vast cosmic distances without being immediately scattered. This was the dawn of visibility, a profound shift in the nature of the cosmos, allowing light to embark on its long journey through space and time. This first light, known as the cosmic microwave background radiation, is a faint ancient glow that still permeates the entire universe today. Following the release of the first light, after atoms had formed and the universe became transparent, a new era began. This period is sometimes referred to as the cosmic dark ages. It was a time before any stars had ignited, so the universe was filled with vast, silent clouds of hydrogen and helium gas, drifting through an immense unlit darkness. This darkness was not empty or desolate, but rather a period of quiet anticipation, a canvas upon which the future stars and galaxies would eventually be painted. Imagine this serene expanse, a universe patiently waiting, holding its breath before the next great act of creation, a tranquil interlude of profound stillness. During these dark ages, which lasted for hundreds of millions of years, the subtle but persistent force of gravity began its slow, tireless work. Tiny variations in the density of the gas clouds, infinitesimally small at first, started to attract more matter towards them. Gravity, the universe's master sculptor, gently tugged at these primordial gases, pulling them together into ever larger concentrations. Think of it as a slow cosmic gathering, a quiet drawing in of material, like unseen currents gently guiding diffuse mists into denser formations. This patient accumulation was the necessary prelude to the birth of the first luminous objects. Eventually, in the densest regions of these collapsing gas clouds, something magical began to happen. As the gas became more and more compressed, the pressure and temperature at the core of these regions soared to incredible levels. Finally, a critical threshold was reached, and nuclear fusion ignited. Hydrogen atoms began to fuse together, releasing tremendous amounts of energy in the process. These were the very first stars, blazing into existence, piercing the long cosmic darkness with their brilliant light. Imagine these first points of light, like newborn diamonds, gently appearing in the vast, dark velvet of space, heralding a new dawn. These first stars were unlike most stars we see today. They were thought to be incredibly massive, hundreds of times the mass of our own sun, and they burned through their fuel very quickly, living short but spectacular lives. Though their existence was fleeting on cosmic timescales, these pioneering stars played a vital role. Within their fiery hearts, they forged heavier elements for the first time, elements beyond hydrogen and helium. When these stars eventually died in massive explosions, they scattered these newly created elements into space, enriching the cosmic medium and paving the way for future generations of stars, planets, and ultimately, life itself. The birth of the first stars was not an isolated phenomenon, occurring randomly throughout the vastness of space. The same relentless force of gravity that ignited these stars also continued to draw matter together on even grander scales. Clusters of these early stars, embedded within their parent gas clouds and surrounded by enigmatic dark matter, began to merge and coalesce. These were the seeds of something even larger, the precursors to the majestic structures that would come to dominate the cosmic landscape. Imagine these stellar nurseries, these infant collections of stars, slowly drifting towards each other, guided by invisible gravitational currents in the immense cosmic ocean. From these initial gatherings of stars and gas, the first galaxies began to take shape. These early galaxies were likely much smaller and more irregular than the grand, well-defined spiral and elliptical galaxies we observe in the universe today. They were more like faint, diffuse collections of stars, small islands of light in the still dark expanse. Yet, they represented a significant step in the universe's organization, a transition from a mostly uniform state to one of increasing structure and complexity. Picture these nascent galaxies, like celestial villages, slowly forming and growing, their combined light beginning to illuminate the surrounding intergalactic space with a gentle, collective glow. Over billions of years, these smaller, primordial galaxies continued to interact and merge. Gravity orchestrated a slow, cosmic dance, with galaxies pulling on each other, colliding and combining to form larger and more massive systems. This hierarchical process of galaxy formation, where small structures merge to build larger ones, is a cornerstone of our understanding of cosmic evolution. It was a gradual, majestic construction project on the grandest possible scale, as the universe slowly sculpted itself into the intricate tapestry we see around us. Feel the serene, unhurried pace of this cosmic evolution, a testament to the patient power of nature. And so, the universe transitioned from a near-uniform state of hot, dense plasma to a cosmos filled with these magnificent star cities we call galaxies. Each galaxy became a home to billions or even trillions of stars, each star a potential sun with its own family of planets. Contemplating this incredible journey from a singular point of origin to a universe teeming with such vast and beautiful structures can fill us with a deep sense of wonder and profound calm. As you drift further into relaxation, let this image of a structured, starlit cosmos soothe your mind, a universe born from a spark, now shining with countless lights. Across the vast, silent theater of space, immense clouds drift in serene majesty. These are the nebulae, the stellar nurseries of the cosmos. They are breathtakingly beautiful, painted with ethereal colors by the light of nearby stars or the glow of their own energized gases. These clouds are composed mainly of hydrogen and helium, the universe's most ancient and abundant elements. Tiny grains of cosmic dust are also scattered throughout, like fine powder in the celestial air. Imagine these gentle giants of gas and dust, suspended in the darkness, holding within them the potential for countless future suns, patiently awaiting the right moment to begin their creative work. For a star to be born, these diffuse clouds must begin to gather. The quiet, persistent force of gravity is the sculptor in this grand cosmic process. Sometimes, a gentle nudge is needed to start this gathering. Perhaps a shockwave from a distant exploding star ripples through the nebula, or maybe the gravitational caress of a passing galaxy provides the necessary impetus. Whatever the trigger, regions within the nebula begin to contract, slowly drawing material inwards. This is not a violent collapse, but a gradual, patient accumulation, as particles of gas and dust drift closer and closer, forming denser clumps in the cold, dark expanse. Deep within these collapsing clouds, at the heart of a swirling knot of matter, a new object begins to form. This is a protostar, the embryonic stage of a star. It is not yet shining by nuclear fusion, the process that powers mature stars. Instead, its gentle glow comes from the heat generated as more and more material falls inwards, compressing the core. Imagine this nascent star, shrouded in its dusty cocoon, growing warmer and denser with each passing millennium. It is a period of quiet growth, a hidden gestation deep within the nebula, as the universe prepares to welcome a new beacon of light. Around this young protostar, not all the infalling material reaches the central body. Some of it settles into a vast spinning disk, known as a protoplanetary disk. This flat structure of gas and dust orbits the protostar, like a miniature version of a spiral galaxy. It is within these swirling disks that planets, asteroids, and comets will eventually form, a natural consequence of star birth. This process, of a star forming with a surrounding disk, seems to be a common occurrence throughout the cosmos. It suggests that the potential for planetary systems, and perhaps even life, is woven into the very fabric of stellar creation. As the protostar continues to gather mass from its parent nebula, its core becomes incredibly dense and hot. The immense pressure builds steadily, like a coiled spring tightening with enormous energy. Millions of years may pass in this gradual compression, a slow, relentless journey towards a critical point. The core temperature climbs higher and higher, reaching millions of degrees Celsius. The atoms within are squeezed closer and closer together, their natural repulsion almost overcome by the crushing force of gravity. Imagine this intense yet controlled build-up of energy, a universe holding its breath before a momentous event. Then, the magic moment arrives. The core of the protostar becomes so hot and dense that nuclear fusion ignites. This is the true birth of a star. In this extraordinary process, hydrogen atoms, the simplest and most abundant, are forced together to create helium atoms. This transformation releases a tremendous amount of energy in the form of light and heat. This is the same process that powers our own sun and, indeed, all stars in the universe. The first spark of fusion marks the transition from a dim protostar to a radiant, self-sustaining star, a new light blazing forth in the cosmic darkness. With the onset of nuclear fusion, a new force comes into play within the star. The outward pressure generated by the energy released from fusion begins to push against the inward pull of gravity. Eventually, a delicate balance is achieved. The outward radiation pressure perfectly counteracts the inward gravitational collapse. This state is known as hydrostatic equilibrium. It is a cosmic balancing act, a stable truce between two immense forces. Once this equilibrium is reached, the star settles into a long period of stability, shining steadily for millions or even billions of years. It has truly come alive. This long, stable phase of a star's life is called the main sequence. Most stars, including our own sun, spend the vast majority of their existence in this phase. During this time, they diligently convert hydrogen into helium in their cores, radiating energy out into space. The length of a star's main sequence lifetime depends critically on its mass. More massive stars are much hotter and brighter, burning through their hydrogen fuel incredibly quickly, living for only a few million years. Less massive stars, like our Sun, burn their fuel more slowly and can shine steadily for billions of years, providing a stable source of energy for any potential life on orbiting planets. Section 3. Stellar Adulthood, the Long and Evolving Journey. As a main sequence star gracefully ages, it continues its primary task fusing hydrogen into helium within its core. This is the quiet, productive adulthood of a star, a period of sustained energy output. However, even this seemingly endless supply of hydrogen fuel is finite. Over billions of years, the hydrogen in the star's core is gradually depleted, converted into a growing core of helium ash. As the hydrogen fuel diminishes, the fusion reactions in the core begin to slow down. This change, though slow, sets the stage for the star's next dramatic transformation, a gentle shift towards its later life stages. With less outward pressure from fusion to support it, the helium core begins to contract under the relentless pull of its own gravity. This contraction causes the core to heat up even further. This increasing core temperature has a profound effect on the layers of hydrogen surrounding the core. The heat from the shrinking core ignites hydrogen fusion in a shell just outside the helium core. This is known as hydrogen shell burning. This new source of energy is even more intense than the previous core fusion, and it pushes the star's outer layers dramatically outwards, like a balloon being gently inflated. For stars like our Sun, this phase marks the transition into a red giant. The star's outer layers expand enormously, sometimes hundreds of times their original size. As these layers expand, they cool down, causing the star's overall color to shift towards red. Though its surface is cooler, the star's total luminosity or brightness actually increases due to its vastly increased surface area. Imagine our Sun, billions of years from now, swelling into a colossal glowing red orb, a gentle giant in its old age, its familiar yellow glow transformed into a soft, ruddy hue. This expansion into a red giant has significant consequences for any planets orbiting nearby. As the star swells, it can engulf its innermost planets. In our own solar system, Mercury and Venus will undoubtedly be consumed when our Sun becomes a red giant. Earth's fate is less certain. It may be swallowed, or it may be scorched and left barren as the Sun's luminosity increases. This is a distant future, billions of years away, a natural part of the stellar life cycle. It is a reminder of the immense scales of time and change that govern the cosmos, a slow, inevitable evolution unfolding across the eons. Deep within the core of a red giant star, like our future Sun, the temperature and pressure continue to rise as the helium ash accumulates. Eventually, conditions become so extreme that a new fusion process ignites. Helium atoms begin to fuse together to form carbon and oxygen. For low-mass stars, this helium ignition can be quite sudden, an event known as the helium flash, though this flash is mostly absorbed within the star's deep interior. Once helium fusion begins in the core, the star finds a new, temporary stability. It shrinks slightly and becomes hotter for a time, continuing its life by converting helium into heavier elements. This new phase of stability, however, is relatively short-lived compared to the star's main sequence lifetime. The helium fuel in the core is consumed much more rapidly than the initial hydrogen. Once the core helium is exhausted, fusion there ceases. The star then enters a phase known as the asymptotic giant branch, or AGB. Fusion of helium and hydrogen may continue in shells around the carbon-oxygen core. During this stage, the star once again expands, becoming even larger and more luminous than before. It also becomes unstable, pulsating gently and losing a significant amount of its mass from its outer layers, shedding them into space as a slow, stellar wind. These expelled outer layers of gas drift away from the dying star, expanding outwards into the surrounding interstellar medium. The hot, dense core of the star, now exposed, radiates intense ultraviolet light. This radiation ionizes the expanding shells of gas, causing them to glow beautifully. This creates one of the most exquisite sights in the cosmos, a planetary nebula. Despite their name, these objects have nothing to do with planets. They are the colorful, intricate shrouds of dying low-mass stars, showcasing delicate structures like rings, bubbles, and lobes. Each one is a unique, ethereal monument to a star's final, gentle release. What remains at the very center of the planetary nebula is the star's former core, a white dwarf. This stellar remnant is incredibly dense, packing roughly the mass of our Sun into a volume similar to that of Earth. It no longer generates heat through nuclear fusion. Instead, it shines faintly due to its stored thermal energy, like a cooling ember. Over an immense timescale, billions upon billions of years, a white dwarf will gradually radiate away all its remaining heat. It will slowly cool and fade, eventually becoming a cold, dark, and invisible black dwarf. This is the ultimate peaceful end for stars like our Sun, a quiet fading into the cosmic night. Section 5. Cosmic Fireworks, the grand finale of massive stars. Stars much more massive than our Sun live very different lives and meet much more dramatic ends. These stellar titans burn through their fuel with incredible ferocity. Their immense gravitational pressure creates extremely high temperatures and densities in their cores. This allows them to fuse not just hydrogen into helium, and helium into carbon and oxygen, but to continue forging even heavier elements. In a series of nested shells like an onion, these massive stars create neon, magnesium, silicon, and finally, iron. Each stage of fusion happens faster than the last, a race against the inevitable gravitational collapse. Iron is a critical turning point for a massive star. Unlike the fusion of lighter elements, the fusion of iron does not release energy. Instead, it consumes energy. Once a significant iron core builds up, the star no longer has an internal energy source to counteract the crushing force of gravity. The iron core, unable to support itself, collapses catastrophically in a fraction of a second. This implosion is incredibly rapid, with the core shrinking from thousands of kilometers across to just a few tens of kilometers. The temperature and density skyrocket to unimaginable levels, triggering a sequence of events that leads to a spectacular explosion. The sudden collapse of the iron core causes the outer layers of the star to come crashing down onto it. These layers then rebound off the incredibly dense core, creating a powerful shockwave that blasts outwards through the star. This is a supernova explosion, one of the most energetic and violent events in the universe. For a brief period, a single supernova can outshine an entire galaxy of billions of stars. It releases a torrent of radiation, neutrinos, and rapidly expanding debris into interstellar space. Imagine this cosmic firework, a star tearing itself apart in a blaze of glory, illuminating the cosmos with its final, breathtaking performance. Supernova explosions are not just events of destruction, they are also crucial for cosmic creation and evolution. The extreme conditions during a supernova forge many of the heavy elements in the universe, elements heavier than iron, such as gold, silver, platinum, and uranium. These newly synthesized elements, along with the star's other layers, are blasted out into space, enriching the interstellar medium. This material then becomes the raw ingredient for new generations of stars, planets, and ultimately, life. From the collapsed core of the supernova, either an incredibly dense neutron star, or, if the original star was massive enough, a mysterious black hole will form, marking the final enigmatic remnant of a once mighty star. Orbiting a modest star, our very own Sun, we find ourselves in a celestial neighborhood teeming with wonder. This star, a glowing sphere of incandescent gas, is the undisputed heart of our solar system. It is the anchor, the life-giver, the constant presence around which all else revolves. Its gentle light and warmth bathe every planet, moon, and speck of dust in its domain. Imagine this radiant star, holding us all in its gravitational embrace. It is a source of comfort and sustenance, a familiar beacon in the vastness of space. Its energy fuels the dance of worlds, a silent, powerful force shaping our cosmic home. Our Sun is a G-type main-sequence star, often called a yellow dwarf, though its light is actually white. It is currently in the most stable phase of its long life, diligently fusing hydrogen into helium deep within its core. This nuclear furnace releases an immense amount of energy, which travels outwards, eventually escaping as light and heat. This energy is the very essence of its power and its gift to the solar system. Though it appears as a gentle disk in our sky, the Sun is vast, over 100 times the diameter of Earth. Its sheer scale is difficult to comprehend, yet its influence is felt intimately by us every single day, a steady, unwavering source of cosmic power. The Sun's immense gravity governs the entire solar system, a gentle yet unbreakable tether. It dictates the paths of planets, comets, and asteroids, orchestrating a slow, harmonious ballet. Each celestial body follows its prescribed orbit, a testament to the predictable laws of physics that shape our universe. This gravitational hold extends far beyond the outermost planets, defining the very boundaries of our solar system. Feel the quiet order of this system, the silent, invisible force that keeps everything in its rightful place. It is a system of balance and rhythm, a grand cosmic dance led by our magnificent star, ensuring stability over eons. The journey of sunlight from the Sun's surface to the planets is a remarkable one. Photons of light, born in the star's core, take thousands of years to reach its surface. Then, they embark on a swift journey across the emptiness of space. This light reaches Earth in just over 8 minutes, bringing with it the warmth that makes our world habitable. It drives our weather, nourishes plant life through photosynthesis, and defines our cycles of day and night. As you relax, picture this gentle stream of light and energy, a constant flow connecting us directly to our star, a golden river sustaining all we know. As we venture closer to the Sun, we enter the inner realms of our solar system. Here reside 4 planets, sculpted primarily from rock and metal. These are Mercury, Venus, Earth, and Mars. They are the terrestrial worlds, sharing a common ancestry in their formation, yet each has evolved a unique and fascinating character. These planets huddle relatively close to their parent star, basking in its intense radiation and warmth. Their surfaces tell stories of volcanic activity, ancient impacts, and the diverse geological processes that have shaped them over billions of years. Let us gently approach these rocky neighbors, each a distinct jewel in the Sun's inner court. First, we encounter Mercury, the swiftest of all planets, racing around the Sun in just 88 Earth days. It is a world of stark contrasts, scorched by the Sun's relentless glare on its day side, while its night side plunges into unimaginable cold. Its surface is ancient, heavily cratered, bearing the scars of countless impacts from the solar system's early chaotic history. Mercury has almost no atmosphere to speak of, leaving it exposed to the harshness of space. Imagine this small, dense world, a silent sentinel forever bound to the Sun's fiery breath, a testament to endurance in an extreme environment. Next, we drift towards Venus, a planet often called Earth's twin due to its similar size and mass. However, Venus is a world veiled in mystery, shrouded by a thick, unbroken blanket of pale yellow clouds. These clouds are not made of water, but of corrosive sulfuric acid. Beneath them lies a surface crushed by immense atmospheric pressure and baked by a runaway greenhouse effect. Temperatures here are hot enough to melt lead, making it the hottest planet in our solar system. Venus spins slowly in the opposite direction to most other planets, its secrets hidden beneath its perpetual toxic veil, a world of intense, fiery beauty. Then, there is our home, Earth, a vibrant blue oasis teeming with life. It is a world of stunning diversity, with vast oceans of liquid water, dynamic continents, and a protective atmosphere that shields us from harmful radiation. Earth resides in the Goldilocks zone, a region where temperatures are just right for liquid water to exist on its surface, a key ingredient for life as we know it. Further out, we find Mars, the red planet. Its rusty hue comes from iron oxide or rust in its soil. Mars is a world of towering extinct volcanoes, vast canyons and dusty plains, showing intriguing evidence of ancient rivers and perhaps even oceans, fueling our dreams of past or present life. Beyond the orbit of Mars, as we journey further from the Sun, we encounter a vast, scattered region known as the asteroid belt. This is not a dense wall of tumbling rocks as sometimes depicted, but rather a wide, diffuse, donut-shaped area. It is populated by millions of rocky and metallic objects known as asteroids. These celestial bodies range in size from tiny pebbles, too small to see, to colossal boulders many kilometers across. The largest among them, Ceres, is so big it is classified as a dwarf planet. Imagine this expansive realm, a silent collection of ancient fragments, each with its own story, drifting in the cold darkness between the inner and outer planets. The asteroids themselves are fascinating relics from the dawn of our solar system, roughly 4.6 billion years ago. They are composed of various materials, including rock, different types of metals like iron and nickel, and some even contain water ice. These are the leftover building blocks, the primordial material that never quite managed to coalesce into a full-fledged planet. They are like cosmic fossils, offering us precious clues about the conditions and ingredients present when the Sun and its planets were first forming. Studying them helps us piece together the grand puzzle of our solar system's birth and early evolution, a scattered archive of cosmic history. The formation of the asteroid belt, or rather the lack of a planet in this region, is largely attributed to the immense gravitational influence of its giant neighbor Jupiter. The powerful gravity of Jupiter, the largest planet in our solar system, stirred up the material in this zone. Its constant tugging and nudging prevented these rocky fragments from clumping together to form a larger planetary body. Instead, they remained as a scattered collection of smaller objects, destined to orbit the Sun in this wide expanse. It is a testament to the powerful forces that sculpt planetary systems, a region shaped by the unseen hand of gravity. This belt of rubble serves as a kind of cosmic frontier, a natural dividing line within our solar system. It separates the smaller, rocky, terrestrial planets of the inner solar system from the colossal gas and ice giants that dominate the outer regions. Crossing this boundary feels like entering a new, grander part of our celestial neighborhood. The asteroid belt is a quiet, sprawling zone of transition, a reminder of the dynamic processes and sometimes incomplete constructions that characterize the universe. It is a serene, yet sparsely populated wilderness of ancient stones, orbiting silently in the Sun's distant light. Leaving the asteroid belt behind, we venture into the realm of giants, the majestic outer regions of our solar system. Here, two colossal planets reign supreme, Jupiter and Saturn. These are the gas giants, worlds of immense scale and entirely different character from the rocky inner planets. They are composed primarily of hydrogen and helium, the same light elements that make up the Sun. They lack solid surfaces in the way we understand them. Instead, their gaseous atmospheres blend gradually into deep, dense interiors. Imagine these immense spheres, swirling with clouds, their sheer size dwarfing anything we have encountered so far on our journey. First, we approach Jupiter, the undisputed king of the planets. It is a world of superlatives, more massive than all the other planets in our solar system combined. Over 1,300 Earths could fit comfortably within its colossal volume. Jupiter's atmosphere is a dynamic tapestry of colorful cloud bands, known as zones and belts, that race around the planet at high speeds. The most famous feature is the Great Red Spot, a gigantic storm, wider than Earth itself, that has been raging for centuries. Jupiter also possesses a powerful magnetic field, the strongest of any planet, and a faint, almost invisible system of rings. Jupiter is not alone in its journey through space. It is accompanied by a vast retinue of moons, forming a kind of miniature solar system. At least 95 moons are currently known to orbit this giant, each a unique world in its own right. Among the most famous are the 4 Galilean moons, discovered by Galileo Galilei in 1610. There is Io, the most volcanically active world in the solar system, constantly reshaping its surface. Europa, covered in a smooth shell of ice, is thought to hide a vast saltwater ocean beneath, a potential habitat for life. Ganymede, the largest moon in the entire solar system, is even bigger than the planet Mercury. And Callisto, ancient and heavily cratered, bears witness to eons of impacts. Next, we drift towards Saturn, often hailed as the jewel of the solar system. While it is the second largest planet, Saturn is most famous for its breathtaking system of rings. These rings are not solid, but are composed of countless individual particles of ice, dust, and rock, ranging in size from tiny grains to mountain-sized chunks. They orbit Saturn in a wide, flat plane, creating an illusion of solid bands of shimmering beauty. Saturn itself is a pale yellow gas giant with a less turbulent atmosphere than Jupiter, but still featuring powerful winds. It too has a large family of diverse moons, including Titan, with its thick, nitrogen-rich atmosphere and lakes of liquid methane, and Enceladus, which spews plumes of water ice into space from geysers near its south pole. Our journey now takes us even further from the sun's warmth into the cold and dimly lit outer reaches of our solar system. Here, we encounter the ice giants, Uranus and Neptune. These planets are smaller than Jupiter and Saturn, but still vastly larger than Earth. They are composed of a higher proportion of heavier elements, often referred to as ices like water, ammonia, and methane, surrounding a rocky core. Their atmospheres are rich in hydrogen and helium, but it is the methane gas that gives them their characteristic bluish hues. These are serene, distant worlds, slowly circling our sun in their far-off orbits. Uranus is a unique and peculiar world, often called the sideways planet. It rotates on its side, with its axis tilted at an angle of about 98 degrees relative to its orbital plane. This means it essentially rolls along its orbital path around the Sun, leading to extreme seasons that last for many Earth years. Uranus appears as a calm, pale cyan sphere, its color derived from the methane in its upper atmosphere, which absorbs red light. It possesses a faint system of narrow, dark rings and a family of at least 27 known icy moons, many named after characters from the works of William Shakespeare and Alexander Pope. Imagine this tilted, serene giant, quietly journeying through the distant cold. Further out still, we find Neptune, the 8th and most distant true planet from the Sun. It is a vibrant, deep blue world, a color also attributed to methane in its atmosphere, though its richer hue suggests another unknown atmospheric component. Neptune is a dynamic planet with the fastest winds in the solar system, reaching speeds of over 2,000 kilometers per hour. It has featured large, dark storms, similar to Jupiter's Great Red Spot, though these appear to be more transient. Neptune also has a faint system of rings and a fascinating collection of at least 14 known moons. Its largest moon, Triton, orbits in a retrograde direction, opposite to Neptune's rotation, and exhibits cryovolcanism, spewing icy materials from its surface. Beyond the orbit of Neptune lies a vast, icy frontier known as the Kuiper Belt. This region is home to countless small, icy bodies and several dwarf planets, including Pluto, which was once considered the 9th planet. Other notable Kuiper Belt objects include Eris, Makemake, and Haumea. These distant worlds are remnants from the early solar system, preserved in the deep freeze of outer space. And even further out, enveloping our entire solar system like a colossal spherical shell, is the Oort cloud. This is a theoretical reservoir of trillions of comets, marking the very edge of the Sun's gravitational influence. Here, in the profound silence and darkness, our solar system gently fades into the interstellar void. For countless generations, humanity has gazed up at the velvet tapestry of the night sky. We have wondered about those twinkling points of light, those distant suns. And with that wonder, a profound question often arises, whispered in the quiet moments of contemplation. Are we alone in this vast universe? This question is as old as conscious thought, a deep stirring within the human spirit. It speaks to our innate curiosity, our desire to understand our place in the grand scheme of existence. It is a question that connects us across cultures and across time, a shared human yearning for cosmic companionship or understanding. The universe, as we have explored, is almost incomprehensibly vast. Billions of galaxies, each containing billions or even trillions of stars, stretch out in all directions. Many of these stars are likely to host their own families of planets, just as our Sun does. When we consider these staggering numbers, the sheer statistical probability suggests that Earth might not be the only cradle of life. Imagine countless worlds, warmed by their own suns, perhaps with oceans, atmospheres, and the right conditions for life to emerge. This thought alone can fill us with a sense of awe and profound humility, a quiet excitement about the possibilities hidden in the cosmic dark. When we speak of life beyond Earth, it is important to approach the idea with an open mind. While we naturally think of life as we know it, based on carbon and water, the universe may hold surprises. Life on other worlds could be vastly different, adapted to conditions alien to us. It might be microbial, simple organisms thriving in unexpected niches, or perhaps, in some far-flung corner of a distant galaxy, complex beings exist, with their own thoughts, their own civilizations. The search for extraterrestrial life is not just a search for mirror images of ourselves, but an exploration of the very potential of existence in all its diverse forms. The implications of finding life elsewhere are profound, whichever way the discovery leans. If we find even the simplest microbes on another world, it would revolutionize our understanding of biology. It would tell us that life is not a unique accident of Earth, but a more universal phenomenon. And if, after long searching, we find only silence, that too would be a significant finding. It might suggest that life, especially complex, intelligent life, is incredibly rare and precious. Either answer would reshape our perspective on ourselves and our place in the cosmos. The search itself is a journey of discovery, a gentle unfolding of cosmic understanding. Section 2. Blueprints of Existence. Lessons from our living world. Our own beautiful planet, Earth, currently stands as our sole example of a world brimming with life. From the deepest oceans to the highest mountains, life has found a way to flourish in an astonishing array of environments. The sheer tenacity and adaptability of life on Earth provide us with crucial lessons as we extend our search into the cosmos. Every creature, every plant, every microbe is a testament to the creative power of nature, a delicate yet resilient expression of biological processes. By studying life here, in all its complexity and simplicity, we begin to understand the fundamental requirements that might allow life to arise elsewhere. One of the most fascinating lessons comes from studying extremophiles here on Earth. These are remarkable organisms that thrive in conditions that would be lethal to most other life forms. We find them in the boiling water of volcanic hot springs, in the crushing pressures of the deep sea trenches, and in the intensely salty or acidic environments. Some microbes can survive extreme cold, high levels of radiation, or even the vacuum of space for short periods. These resilient life forms expand our definition of habitable. They show us that life can exist in niches far more diverse and challenging than we once imagined, opening up new possibilities for where to look. From our understanding of terrestrial life, scientists have identified some key ingredients that seem to be fundamental. Liquid water is often considered the most crucial, as it acts as a universal solvent, facilitating the chemical reactions necessary for life as we know it. An energy source is also vital, whether it comes from a parent star, like our Sun, or from chemical reactions in a planet's interior, such as those powering life around hydrothermal vents. Furthermore, the presence of organic molecules, rich in carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, appears to be essential for building the complex structures of living organisms. These lessons from Earth guide our search for life beyond our world. We look for planets or moons that might possess these key ingredients, evidence of liquid water, a source of energy, and the presence of organic compounds. This does not mean that life elsewhere must follow Earth's blueprint exactly. However, starting with what we know provides a logical and scientifically sound approach to a very challenging quest. It allows us to focus our search on environments that, based on our current understanding, offer the most promising conditions for life to take root and perhaps to thrive in quiet solitude. Section 3. Whispers in our cosmic backyard, exploring nearby worlds. Our search for life naturally begins close to home, within our very own solar system. While no complex, intelligent aliens are expected to reside on our planetary neighbors, the possibility of finding microbial life, either past or present, remains an intriguing prospect. Mars, the red planet, has long been a prime candidate. Observations have revealed ancient riverbeds, deltas, and minerals that form in the presence of water. This suggests that Mars was once a warmer, wetter world, potentially capable of supporting life. Rovers like Curiosity and Perseverance are diligently exploring its surface, searching for signs of past microbial ecosystems preserved in the Martian rocks and soil. Beyond Mars, some of the icy moons orbiting the gas giants have emerged as highly compelling targets in the search for life. Jupiter's moon Europa is particularly tantalizing. Beneath its smooth, icy shell, scientists believe there lies a vast, global ocean of salty, liquid water. This ocean could contain more water than all of Earth's oceans combined. Tidal forces from Jupiter's immense gravity constantly flex Europa, generating heat in its interior. This could potentially create hydrothermal vents on the floor of its hidden ocean, similar to those on Earth that support vibrant ecosystems, completely independent of sunlight. Imagine a dark, deep ocean warmed from within, perhaps harboring life. Saturn's small moon Enceladus is another fascinating ocean world. The Cassini spacecraft made the astonishing discovery of plumes of water ice and organic molecules erupting from geysers near its south pole. These plumes strongly suggest the presence of a subsurface liquid water ocean, also likely warmed by tidal heating. The composition of these plumes, containing water, salts, silica dust, indicative of hydrothermal activity, and simple organic compounds, makes Enceladus one of the most promising locations in our solar system to find currently existing extraterrestrial life. It offers a direct sample of its ocean, a gentle whisper of its hidden potential. Even Saturn's largest moon, Titan, presents a unique, albeit different, environment of astrobiological interest. Titan has a thick, nitrogen-rich atmosphere, and on its surface, rivers, lakes, and seas of liquid methane and ethane exist. While water is frozen solid at Titan's frigid temperatures, the presence of liquid hydrocarbons raises the possibility of a different kind of life, one that uses methane as a solvent instead of water. The complex organic chemistry occurring in Titan's atmosphere and on its surface makes it a natural laboratory for studying the pathways to life, even if that life is profoundly different from our own. Our solar system, it seems, still holds many secrets. Section 4. Distant Worlds, Faint Clues. The Exoplanet Revolution. For centuries, the existence of planets orbiting other stars was purely theoretical, a dream of philosophers and astronomers. But in recent decades, that dream has become a stunning reality. The discovery of the first exoplanet, a planet outside our solar system, in the 1990s, opened a new window onto the cosmos. Since then, thanks to dedicated missions like NASA's Kepler Space Telescope and the Transiting Exoplanet Survey Satellite TESS, thousands of exoplanets have been confirmed. We now know that planets are incredibly common, likely outnumbering the stars themselves. Our galaxy alone may be home to hundreds of billions of planets, a staggering thought. These exoplanets are detected through ingenious, indirect methods. The most prolific technique has been the transit method, used by Kepler and TESS. This involves monitoring the brightness of countless stars. If a planet passes in front of its star from our line of sight, it causes a tiny periodic dip in the star's light. Another successful technique is the radial velocity method, or wobble method. It detects the slight gravitational tug a planet exerts on its parent star, causing the star to wobble back and forth. These subtle signatures, observed from light years away, allow us to infer the presence, size, and orbit of these distant worlds, painting a picture of diverse planetary systems. Among the many exoplanets discovered, scientists are particularly interested in those that orbit within their star's habitable zone. This is often called the Goldilocks zone, a region around a star where the temperature is just right for liquid water to potentially exist on a planet's surface. Finding rocky planets, perhaps super-Earths, larger than Earth but smaller than Neptune, or even Earth-sized worlds, within these habitable zones is a key goal. While being in the habitable zone doesn't guarantee life, it does mark a planet as a prime candidate for further investigation, a place where conditions might be favorable for life as we know it. The next great challenge is to search for biosignatures on these promising exoplanets. Biosignatures are signs of life that can be detected remotely, such as specific gases in a planet's atmosphere. For example, the presence of abundant oxygen, along with methane, in an exoplanet's atmosphere could be a strong indicator of biological processes similar to those on Earth. Future powerful telescopes, like the James Webb Space Telescope, are designed to analyze the light passing through exoplanet atmospheres. By studying the chemical composition of these distant atmospheres, we hope to find the subtle fingerprints of life, transforming a point of light into a potential living world. Section 5. Listening to the Void, the Search and its Profound Silence. As we search for life, especially intelligent life, A perplexing question arises, famously known as the Fermi paradox. If the universe is so vast and old, and if planets capable of supporting life are common, then why haven't we encountered any definitive evidence of extraterrestrial civilizations? Where is everybody? This great silence, as it is sometimes called, is a profound cosmic mystery. There are many potential explanations, ranging from the idea that intelligent life is incredibly rare, to the possibility that civilizations don't last long enough to make widespread contact, or perhaps they are simply too alien for us to recognize. This intriguing silence has not deterred the search for extraterrestrial intelligence, or SETI. For decades, dedicated scientists and enthusiasts have been systematically scanning the skies, listening for artificial signals that might betray the presence of a technological civilization. Using powerful radio telescopes, these projects listen for narrow-band signals, patterns that are unlikely to be produced by natural astrophysical phenomena. It is a patient search, like listening for a single faint whisper in a vast cosmic ocean filled with natural radio noise. So far, no unambiguous signals have been detected, but the search continues, driven by hope and the immensity of the unknown. The challenges of interstellar communication are immense. The sheer distances between stars mean that even if a signal were detected, a two-way conversation would take decades, centuries, or even millennia. What kind of message would we send, and how could we ensure it would be understood by a truly alien intelligence? Humanity has made a few modest attempts to send messages into space, such as the Arecibo message transmitted in 1974, carrying basic information about ourselves and our world. These are like messages in a bottle, cast into the cosmic sea with no expectation of a swift reply, but as a testament to our own curiosity and desire to reach out. The search for extraterrestrial life, in all its forms, is an ongoing human endeavor. Whether we are sifting through Martian soil, analyzing the plumes of icy moons, studying the atmospheres of distant exoplanets, or listening for faint signals from the stars, it is a quest that expands our horizons and deepens our understanding of the universe. The journey itself is valuable, fostering scientific discovery and philosophical reflection. As you drift into peaceful rest, consider this grand, quiet search. It is a testament to our enduring hope, our boundless curiosity, and our profound connection to the vast, mysterious cosmos that surrounds us, a universe waiting to share its secrets. Section 1. Returning to the Moon, a stepping stone to deeper space. Humanity once walked on the moon. Those iconic footsteps echoed a promise of future journeys. Now, a new and exciting era of lunar exploration is gently dawning upon us. Many nations, and indeed private companies, are turning their hopeful gaze back towards our closest celestial neighbor. The moon beckons us once more, not merely as a destination to visit, but as a crucial stepping stone towards the deeper reaches of space. It holds ancient secrets about the formation of our solar system. It also offers a unique vantage point for observing the vast cosmos beyond, its silent, serene surface patiently awaiting our gentle return. Future missions to the moon aim to establish a more sustainable and lasting human presence there. We envision small outposts, and perhaps one day, even permanent bases, carefully nestled among its ancient craters and vast, dusty plains. These lunar habitats could serve as invaluable laboratories for a wide range of scientific research. Scientists could study lunar geology in detail, investigate the long-term effects of the space environment on equipment and life, and conduct astronomical observations, free from the distorting veil of Earth's atmosphere. The moon's shadowy polar regions, which hold precious deposits of water ice, offer a critical resource for these future endeavors. This ice can be transformed into drinking water, breathable air, and even rocket fuel. Section 2. The Martian Frontier, humanity's next great leap. Mars, the enigmatic red planet, has long captured our collective imagination and inspired countless dreams of exploration. It glows with a soft, rusty hue in our night sky, a distant beacon of immense curiosity and wonder. For many decades, we have sent sophisticated robotic emissaries to diligently explore its dusty plains, its towering extinct volcanoes, and its vast canyon systems. These intrepid rovers and observant orbiters have slowly painted a fascinating picture of a world that was once much warmer and significantly wetter than it is today. Their findings hint at the tantalizing possibility that Mars may have once harbored simple forms of life. Now, the enduring dream of sending humans to walk upon its alien surface feels closer than ever before. Humanity stands on the very precipice of this next great leap. Our intelligent robotic explorers continue their vital and tireless work, meticulously paving the way for the eventual arrival of human astronauts. They carefully map the varied terrain, analyze the thin, cold Martian atmosphere, and diligently search for crucial resources like subsurface water ice. These robots act as our indispensable scouts, identifying potential safe landing sites and rigorously testing new technologies in the harsh Martian environment. Each precious piece of data they transmit back to Earth is another stepping stone, gradually reducing the inherent risks for future human crews. These tireless machines are the very vanguard of our Martian ambition, silently and patiently preparing the ground for the first historic human footsteps on another planet, a truly monumental undertaking. Section 3. Beyond the Inner Planets, Reaching for New Horizons. While the familiar landscapes of the Moon and the rusty plains of Mars capture much of our immediate attention and resources, the irresistible call of the cosmos extends far beyond these relatively close neighbors. The vast outer solar system, with its colossal gas giants and numerous enigmatic icy moons, holds profound and captivating mysteries waiting to be uncovered. Future advanced robotic missions will bravely venture into these distant, cold, and dimly lit realms. These sophisticated probes will carry suites of cutting-edge instruments to meticulously probe the turbulent atmospheres of Jupiter and Saturn. They will explore the incredibly intriguing ocean worlds like Europa and Enceladus, which scientists believe may harbor vast liquid water oceans, and perhaps even life, hidden beneath their thick, icy crusts. The dedicated search for life in the potential subsurface oceans of these distant, icy moons is a particularly compelling and scientifically rich endeavor. Jupiter's moon Europa, with its smooth, cracked, icy shell covering what is thought to be a vast, global saltwater ocean, and Saturn's moon Enceladus, with its spectacular plumes of water ice and organic molecules erupting into space, are prime candidates. Future missions might be specifically designed to land gently on these frigid, icy surfaces. Some concepts even envision deploying advanced submersible robots that could melt their way through the ice and explore the dark, alien waters below. Imagine a small, brave probe descending through kilometers of solid ice, finally entering a hidden ocean and searching for signs of life. Section 4. A Shared Cosmic Destiny, Collaboration and Inspiration. The grand and ever-expanding endeavor of space exploration is increasingly becoming a truly global pursuit, transcending national borders and political differences. Ambitious and complex projects, such as sending human missions to Mars or constructing the next generation of large space telescopes often require immense resources and highly specialized expertise that lie beyond the capacity of any single nation acting alone. International collaboration is therefore becoming not just beneficial, but absolutely essential. Such cooperation fosters a powerful spirit of unity and shared purpose among people from diverse backgrounds. When nations work together, pooling their unique talents and advanced technologies, we can achieve far more magnificent things than we ever could in isolation. Space exploration can be a potent force for peace. We are also witnessing the exciting and dynamic rise of a vibrant commercial space sector, with private companies playing an increasingly significant role. These innovative enterprises are developing new and reusable launch vehicles, building constellations of satellites for various purposes, and even planning their own independent missions to the moon and potentially beyond. This growing commercialization of space is helping to make access to space more affordable and more frequent than ever before. It fosters healthy competition, drives technological innovation, and creates entirely new opportunities for scientific research, space tourism, and the potential utilization of space-based resources. The synergy between government space agencies and private enterprise is powerfully accelerating the overall pace of exploration and development. Section 1. Echoes of awe embracing the universe within. Our shared journey through the cosmos is now drawing to a gentle, peaceful close. We have traveled so very far together tonight. We have crossed billions of years in our minds. We have soared across countless light years of silent space. We saw the universe's very first fiery breath. We watched the quiet, majestic dance of distant galaxies. We explored the incredible lives of stars from their misty, ethereal cradles. We saw their sometimes soft, sometimes spectacular goodbyes. Let these profound memories of cosmic grandeur settle softly within you now. Feel the lingering, gentle sense of wonder they bring. We journeyed through our own familiar solar system, a special place we call home. We visited planets of rock and fire, close to our sun. We floated past giant worlds of gas and distant, mysterious, icy spheres. We pondered the deep, eternal question of life beyond our small Earth. We looked with gentle hope towards humanity's future among the stars. Each new discovery, each unfolding layer of understanding, was meant to enlighten your mind. It was also meant to soothe your soul. Allow all these thoughts to become a soft, comforting background hum. Let them be a gentle, cosmic lullaby of knowledge washing over you. The incredible vastness we have explored together is not truly separate from you. Please know this. You are a cherished child of the cosmos itself. You are quite literally forged from ancient stardust, the iron that flows in your blood, giving you strength, the calcium that builds your bones, giving you form. These elements were created deep within the fiery hearts of long-ago stars, stars that lived and then gently died. Feel this profound, unbreakable connection in the quiet, deep stillness of this moment. You are not merely an observer of this grand universe. You are an intrinsic, vital part of its magnificent, ever-unfolding story. Let this simple truth bring you a deep, comforting sense of belonging. As the narrative of our extensive journey gently fades into the background, let the pure serenity of space itself begin to envelop you. Imagine the quiet, boundless, soft expanse that surrounds everything, holds everything. This immense, profound peace is always present, always here. It is always available to you, whenever you seek it. We now turn our full attention towards this inner calm, this inner peace. We prepare for a deeper, more restorative rest. Let the fading echoes of cosmic awe gently guide you. Let them lead you into a state of profound, unwavering tranquility. The great cosmic ballet continues its silent dance, and you are in perfect, peaceful harmony with it. Section 2. Cosmic Rhythms. Breathing with the Stars. Let us now gently turn our focus to your breath. Your breath is your quiet, faithful anchor to this present moment. Breathe in slowly, softly, deeply now. Feel the clean, cool air as it enters your body, filling your lungs completely. Imagine, if you wish, that you are drawing in the pure, calm, healing energy of the cosmos itself. Feel the gentle, natural expansion in your chest, in your abdomen. It is like the universe itself, always expanding, always creating. With each soft inhalation, you connect more deeply to the ancient, steady rhythms of all existence. There is nowhere else you need to be. There is nothing else you need to do. Simply be, simply breathe. As you exhale, let it be a soft, slow, complete release of air. Imagine any lingering tension, any small worries or busy thoughts, gently flowing out from you with your breath. Let them dissolve effortlessly into the vast, forgiving expanse of space. Watch them become distant, fading whispers, losing all their power. Feel your body becoming heavier, softer, more deeply relaxed with each quiet, outward breath. Your shoulders gently drop, your facial muscles soften and smooth, your limbs feel wonderfully heavy and at ease. You are completely safe. You are held and supported in this peaceful, tranquil moment. Picture the countless stars in the night sky, if you will. Imagine them breathing with a slow, silent cosmic rhythm. They gather light and immense energy over vast eons of time. Then they gently radiate this light and energy outwards into the universe. Your own breath can mirror this serene, powerful pulse of creation. Inhale calm, deep peace. Exhale any remaining disquiet, any restlessness. Feel the undeniable connection between your own precious life force and the vibrant, creative energy that animates the entire universe. You are breathing with the stars. You are breathing with the swirling nebulae. You are breathing with the silent, graceful turning of galaxies. This rhythm is ancient. It is profoundly soothing. It is deeply restorative for your mind and body. With each gentle cycle of your breath, allow yourself to sink deeper and deeper into relaxation. Feel the steady, comforting support beneath you. It holds you securely. It cradles you gently. The universe is a place of immense, beautiful cycles. It has cycles of expansion and gentle return, of activity and rest. Your breath is an integral part of this grand, natural, harmonious pattern. Trust in this inherent rhythm. Let it carry you effortlessly, without any striving towards a state of profound inner stillness. This is your inner sanctuary, a place of quiet, undisturbed peace. Your mind becomes wonderfully clear. Your spirit feels beautifully calm and centered. Section 3. Celestial Slumber, a gentle drift into peace. Now, as our cosmic journey together truly concludes, it is time to let go completely. Allow all the wonders of space we have witnessed to become gentle, peaceful companions in your mind. See them as soft, shimmering images, gently guiding you towards deep, restorative rest. There is no longer any need to hold on to any particular thought, any specific image. Simply allow your awareness to float, to drift peacefully. Imagine you are nestled comfortably in a soft, warm cloud of cosmic dust. You are entirely safe. You are utterly serene. The universe itself is gently cradling you now, holding you in its vast, loving embrace. Picture a slow, gentle, effortless drift through an infinite field of distant, twinkling stars. They are like tiny, peaceful diamonds, softly scattered across a deep velvet sky. Their ancient light is incredibly soothing, calming to your eyes and your mind. Feel yourself moving effortlessly and silently among them. You're a quiet traveler in a realm of boundless, infinite peace. Beautiful nebulae, with their soft, ethereal, dreamlike colors, glow gently in the far distance. Their silent beauty is a soft, visual lullaby for your tired senses. Let this gentle cosmic scenery soothe your soul and ease your mind into complete tranquility. With every passing moment, with every gentle breath, you drift further and further into relaxation, deeper and deeper into a state of profound, peaceful tranquility. The vastness of space, which once might have seemed empty, is now filled with a profound, comforting silence. This immense silence envelops you like a warm, soft, protective blanket. Feel the gentle, welcome pull of sleep, a sweet invitation to rest your body and rejuvenate your spirit. The universe watches over you with its countless benevolent stars. They are like ancient, silent guardians of your peaceful slumber. You are cherished. You are safe. Allow the many wonders of space, its beauty and its peace, to cradle you gently into a deep and restful slumber. Let the profound peace of the cosmos be your constant companion tonight and every night. Breathe deeply and slowly one last time, and with your final exhalation, let go a little more. Let go completely. Drift peacefully now into the soft, healing, welcoming embrace of sleep. May your dreams be filled with gentle, twinkling starlight. May they echo with the quiet, serene majesty of the universe. Rest well, dear cosmic traveler. Rest deeply. Rest well.